All right, we're going to take a look at fibers now from the PowerPoint that you have posted. You're going to complete the notes for the fiber section as well. And some of the material that you will need for the notes may be found in the textbook. So please make sure you refer back to that if needed. All right, so with fibers, the main thing with fibers is knowing the types of fibers. That's one thing we're going to focus on, the classification. And I will post a worksheet to help you break that down a little bit. That'll be posted on Monday. So when you take a look at these images, most of these pictures are actually cross-sectional views because many of those types of fibers are man-made fibers, and basically they can be designed in any way that the manufacturer needs them to be. So when you look at those cross sections, you have these Y shapes. They call that a trilobal shape. You have some kind of like a triangular shape here, and these are actually hollow to a certain degree in the middle, depending on, again, what you need the purpose of that fiber to be. All right, so fibers as evidence. Something that we're going to be discussing in terms of the evidence value of hair and fiber is do you have a lot of the fibers present or do you have nothing present? Also, the rarity or the commonness of the type of fiber. So something like cotton, especially just white cotton, that is the most common fiber that you can find. And if you have that at a crime scene, that would be extremely difficult to match to a particular person because pretty much everybody has something in their possession that's made out of white cotton fibers. So if you have something like that, that might not be as useful. But if you do have maybe a strange dye color or a fiber that's not normally used, then that can give you a little bit more leeway in what you're looking at. Also, the number of fibers that you have, the number of fibers or lack of fibers, we have to think about that. If you think about the Melissa Brennan case that you're watching the movie for, the fact that there were fibers in the suspect's car, yes, that's very important. Those fibers were very specific fibers with very specific colors. But if there weren't any fibers, then maybe that could lead you to think that either A, she was never in his car, or B, maybe she was wrapped up in something and a crime already occurred. So when you look at the scenario and the presence or absence of fibers, that is an extremely important idea to keep in the back of your head. Also, the location of fibers on a victim or suspect help recreate the scene. In the Wayne Williams trial, they noticed that some of the victims had carpet fibers in their hair, but not on the rest of their body. This led the investigators to believe that the bodies were dragged along the floor. And as the head dragged on the floor, the hair of those victims picked up the fibers. So it's very telling in a situation like that when you have fibers in a particular location on the body. So the classification of fibers, the main two groups. So if you were to make a little diagram, which is what I'm going to post for next week to help you review this, if you had two branches coming down from the word fibers, you would have natural and manufactured. Natural fiber is animal or plant-based. So we've discussed animal fibers already. That would be basically animal hairs. So things in like fur coats, if you have something like wool or silk, those are all animal fibers. Plant would be your cotton or your flax, linen, things like that. Manufactured fibers. These are fibers that are made in a factory. And very typical ones, nylon and polyester and rayon, you have all of those. They're basically made chemically and they're forced through a machine called a spinneret. The spinneret is what is going to give you, if I could just go back a little bit, is what's going to give you these shapes that we have here. So the spinneret is like a mold where you force the chemicals through, and they're going to form that fiber, that thread, based on the shape of that the spinneret mold is using. Okay, and you could see that, fabrics like rayon, nylon, those particular textiles were made of, the rayon and the nylon fibers that are manufactured in the early 1900s. Now, manufactured fibers can be broken down into two groups. They can be broken down into regenerated or synthetic. Regenerated, think about if something regenerates, it comes from something else, it's growing from something else. A regenerated fiber is a fiber that has raw materials that are natural. So you can have something like the cellulose in a plant, which is that structural molecule, that you find in plants and trees. It's going to be taken and chemically treated. So that cellulose is no longer a natural material. It's been chemically treated, and then that particular mixture is going to be forced through the spinneret to get the shape. So for regenerated fibers, the most common ones would be rayon, acetate, and triacetate. And if you think about rayon, rayon is kind of like a manufactured silk. Okay, it has that shine to it. It has that silkiness to it. Synthetic fibers. Synthetic is not natural at all, totally fake. So it's solely made from chemicals. This is your nylon, your polyester, and your acrylics. Synthetic fibers are polymers. And again, a polymer we've talked about in other topics. It's when you have many repeating molecules linked together. So again, we have a couple of examples of the different types of shapes that you can have with these manufactured fibers. So we have on the left here the dumbbell shape. You have a trilobal shape, a polyester shape, because of the 3 lobes that come off of the central area. You have nylon here, which has 4 hollow canals down the center of the fiber. And you have one that is just hollow altogether. And again, depending on the use that the fiber is going to have, manufacturers can design how that fiber will be formed and give it different shapes. We talked about the polarizing microscope and the fluorescent microscope, where you can pass different types of light. So this picture of nylon and polyester shows other types of light being passed through the fibers, and it gives it those really unique colors. So you can see this is, the bright pink, and then you have the blue and the yellow where you have that overlap of the threads and a higher concentration of those chemicals. But you can see this would be a regular compound microscope. You can see the morphology of the fibers. You can look at diameter. You can look at the dyes, the pigment distribution. Right, very similar to hair evidence. So when you are identifying and comparing manufactured fibers, the value that they have as evidence in a crime is to try and trace the fiber back to its origin, which again can be very difficult. So what are we going to look for? We're going to look for color and diameter. All right, you can use a comparison microscope for that. This is very similar to what they did in the Melissa Brennan case, where they were trying to find that fiber of that outfit that she was wearing, that one very specific outfit. Lengthwise striations. So if you think about a fiber being pushed through a mold to be formed, there could be striations along the edges of that fiber. I always say that the spinneret process is similar to like when you were a kid, if you had like one of those Play-Doh toys where you put the Play-Doh into the little basket and then you pulled a lever and forced it through to make different shapes. That's basically how a spinneret works. So as those fibers are being forced through the spinneret mold, you can have those striations along the sides. And that could be something that's unique to the manufacturer that made them. Pitting of the fiber surface with delustering particles. Many fibers, when they're manufactured, are extremely shiny. They have a high luster to them. And titanium dioxide is used to deluster those fibers. So if you think about a white cotton t-shirt after it's been cleaned and bleached and woven into a textile, imagine it reflecting light to the point where your shirt was almost shiny. So what they do is they treat certain fibers with titanium dioxide to get rid of that shine and that luster. And as a result, you get pitting in the surface. It roughs up the surface a bit. And then also the cross-sectional shape, which we've seen examples of. So in the Wayne Williams trial, there was that unusual yellow-green fiber with that, that unique shape also. So along with the color and the diameter for those manufactured fibers, that cross-sectional shape is very useful. The dye comparison. So there is something called a microspectrophotometer. It's a microscope where you just can observe the specimen, but it also has a spectrophotometer on it where it will give you a chemical composition, specifically in this case, the dyes. So if you have one particular manufacturer making textiles and making the fibers, you can identify the chemicals that they're using and you can try to match that up to the crime scene sample. Chemical composition, again, of just the fiber itself. So if you look at nylon, there's not just one type of nylon. There's going to be at least 4 different types. Acrylic, even more. Polyesters, there's a ton of different types of polyester. So depending on the type and the manufacturer who made it, you have different chemical compositions. And again, for the manufactured fibers, that birefringence. So we talked about the polarizing microscope, the birefringence pattern, and the image you get with a polarizing microscope can help make a match as well. So the significance of a match. Now we're getting to the evidence value of the fibers. You're basically trying to get as close to a match as you possibly can, or be able to say that, yes, it is possible they came from the same fabric or the same piece of clothing. We don't have a database to determine this, because if you think about how many articles of clothing are out there and how many different manufacturers of fiber and textiles there are, in essence, you really cannot definitively match a fiber to a single garment. It's very difficult. So when a textile company uses fibers to make a fabric, that fabric could be sold to literally hundreds of different manufacturers making different pieces of clothing. So it's very difficult to say with 100% certainty that this fiber came from this fabric. All you can say is, yes, they are consistent with each other, which could be significant in certain cases. Now, if you're able to link 2 or more different fibers to the same object, then you're starting to build that class evidence. Okay, so remember the class characteristics. The more you have, the more you're corroborating with that evidence, and they are in fact helpful. All right, so that is the end of our fiber section of the PowerPoint. Again, please make sure you are using the textbook posted for the fiber section to complete the notes. All right, have a great day, guys.